Managing packages. In this nugget, we're going to talk about the object called a package that's actually stored in the data dictionary, and it's simply a way of organizing your procedures and functions and other variables that go along with that. If you come from a Java background, a package in PL/SQL is a lot like a package in Java, where it's just a nice way of organizing all of your stuff. So we'll discuss, well, why would we want to use packages as opposed to standalone procedures and functions? Then I'll talk about some common packages that we use that Oracle has already provided for us that we have access to. In fact, you've already been using packages from day one. There's a package called Standard that we'll talk about, and we'll look at some other common ones. Then I'll show you how to create your own packages so other people can use them, and we'll talk about the different privileges required to use those packages. And then we'll delve into our data dictionary to find out information about existing packages that you own or that you have access to. Why would we want to use a package? Well, the main reason is ease of maintenance with your programs. Take a look at the diagrams down below here. Here we have, let's assume that app 1 is a package and app 2 is a package as well. You can have procedures and functions with the same names inside of those packages, and they have their own namespace. In other words, there's no collision in names. So imagine that you're a developer for a company and you've got hundreds upon hundreds of procedures and functions that you're developing. It just makes it much easier to organize your stuff. What's also really cool about packages is that within your package, you can pass around session variables. For example, if my procedure 1 here sets a session variable called var1, it can be passed around to f2 and so on. We can also hide information. Okay, so when you're creating a package, there's two different parts to it. There's the specification and the body. The specification is what's visible to everyone who has execute privilege on the package. The body can actually contain some hidden stuff. In fact, you can wrap up the body code and encrypt it so no one can see anything inside of the body. But the body is really what's getting the stuff done. Think of it in terms of if you're a C or a C++ programmer having the header files. In other words, anything that you put in the specification is visible. Anything that you put in the body is invisible. As far as creating PL/SQL applications, you can call these packages from your application, and that way you have just a big picture view of what your application is doing. You don't have to look at the fine-grained details. Another nice thing is once you load anything from your package into your session, it actually loads the whole package, and it stays in your session until you end your session. So you don't have all this loading and unloading and compiling going on. Oracle's already defined hundreds of packages for us. In fact, the most common package that you've already used is the standard package. This is the default package. In other words, you don't have to fully qualify this package to use it. When you perform a commit or a rollback or use any of the functions like round, those are all belonging to the standard package. Let me show you what I'm talking about. Here we have select round of 3.14 from Dual. Here in this next example, I'm fully qualifying it. This round belongs to the standard package, which belongs in sys's schema. The standard package is the only one that's the default, the only one that you don't have to fully qualify when you're using it. Now, if you're curious to see what exactly is inside of a package, you can always say describe and then the package name. I'm not going to hit enter because this is going to give us a lot of information back, but feel free to do this on your machine. Here's another example. The trim function also belongs to that standard package. We organize our packages according to functionality. So one of our packages is dbms output, and this has to do with splashing output to the screen. So here's my example of using it. dbms output package has a procedure called putLine. It takes one argument, which is some kind of string, and then it splashes it to the screen. So to make this work, though, you need to say set server output on. And set server output on is actually a SQL plus command. So then we execute it and it printed out Bob. Once again, the quick and dirty way of finding out what's in your package is to do a describe on the package. Now it might be tempting to do a describe on the package dot and then procedure name, but you can't do that. You have to display everything in the package. So here we go. And I find it sometimes a little tricky to read, but it just takes a little bit of patience. We're looking for the put line, There it is, procedure put line, and it tells us how many arguments it takes, so just one, and the data type, whether or not it's an in or an out parameter, and whether there's a default value. Another common package is DBMS stats. This helps us generate statistics on our database objects such as tables and indexes. The whole purpose for statistics gathering is to allow our cost-based optimizer, which is an internal Oracle feature, it helps it optimize our queries so we have better performance. So we'll talk more later about the cost-based optimizer, but that's really what it's doing. It's gathering stats, such as how many rows does my table have, what's the average length of my row in the table. So if you're a regular user, you can call gather table stats, you can call gather index stats, gather schema stats. If you're logged in as a sysdba, you can gather the database stats. That kind of procedure can take a long time. I've seen it take several hours. You don't see any output here except that the procedure successfully completed, but we do trust that these statistics are there. And you can then go into the data dictionary for user tables or for DBA tables, look at the last analyzed column and see the time and the date, if you want to, of when that object was analyzed. Here's a useful package, the DBMS scheduler. This is a nice and easy way of scheduling things to happen in the future, either on a one-time basis or on a recurring schedule, kind of like a cron job if you're familiar with Unix. If you've ever done any work with Oracle 9i or earlier, we had a package called DBMS job, but DBMS scheduler is a little more modularized. They both schedule jobs. To be able to schedule a job, you have to have the create job privilege. So notice here I'm logged in as a sysdba and I said grant create job to Scott. And from my block of code here, I'm calling my create job procedure in this package. So the job name has to be a unique name. Okay, we'll call this get schema stats. Job type can either be a PL SQL block, it can be a shell script, it can even be a piece of Perl code. This is what makes this a little easier to deal with rather than DBMS job where you're just limited to PL SQL. And then the job action. So here is where we are calling DBMS stats. So we're actually utilizing two different packages in this chunk of code. Gather schema stats, we're gathering it for Scott. Now why in the world would we have double single quotes here? Well, see how this whole string here is enclosed in single quotes? By putting two single quotes, we're escaping it. So this is actually rendered internally as one single quote. If you wanted to find which procedures and functions are available in your package, you can simply do a describe on the whole package like this. Describe and then the package name. You cannot drill down to any procedure or function. You have to list the whole package. And you'll see that a lot of stuff here is splashing across the screen. If you don't have enough buffer space in SQL+, you can always spool this to a file and then look at the spooled out file. Okay, so there we go. We've got our procedures and functions defined here. So here, for example, procedure set attribute, it shows us which parameters are required and whether or not they have a default value. For these larger packages, I find it almost easier just to go to the official documentation and look it up online. It's just a little easier to read in an HTML file. You've learned how to use packages that are already created for you. How about creating your own package? Well, to do that, you decide on a name for your package. So here in this example, my package is called miscellaneous, or MISC. It's a two-step process. You're going to create, first of all, the specification. Think of the spec as being what the outside world can see. For example, if you're defining any constant variables that you want to let the outside world access directly, if you have any procedures or functions in your spec, then all you're going to do is show the name of the procedure or function, what parameters it takes, and if it's a function, say what type of data it returns. But you're not actually going to put the real code in there. You wait until your package body to actually implement it. So if you've come from a C or C++ background, this is kind of like the header files. So let's take a closer look here at our syntax. We say create a replace package and then the package name as, and then here is where you define any variables, constants, exceptions, and if you've got pragma init exception like we did in our procedure and function chapter. If you have any procedures or functions, you would put them here. Now, your package doesn't have to contain any procedures or functions. For example, you might have a package that just defines a bunch of constants or variables, and that's it. So then you have your end statement that wraps up the whole package. I like to say end and then the package name. It's not required though. You can simply just say end. Let's look at the syntax for our package body. Create or replace package body and then the package name as. And that's where you actually implement your procedures and functions. So keep in mind that the signature is the list of parameters that your procedure or function takes. It has to match your specification exactly. Otherwise, you'll get a compilation error. So down here, we're defining our procedure. So let's take a look here. Our procedure definition is right in here, and then here's our function definition. Okay, once again, I like to say end, and then the name of the procedure or the function, and at the very end you say end and then the package name. It just makes it a lot easier to read. Well, here's an example of a real minimal package. I'm calling mine miscellaneous, and all I'm doing is defining a constant variable, and that's it. So here's my package spec. Since I don't have any procedures or functions, I don't even need a package body. So now to test it, I'm creating a bind variable called C. I'll have it be varchar2, maximum of 30 characters. And all I'm doing on line 2 is assigning to it the value of my company name. And then we can just print out our C value and see that we can directly access it. See that? Acme Company. Now, if you want to dig this information out of the data dictionary, if you're logged in as the sysdba, you can query dba underscore source. If you're logged in as a regular user, you can query all underscore source or user underscore source, and you can get information about your procedure or function or package. So all of these are in the same namespace as far as the data dictionary is concerned. In other words, if you've got a package called miscellaneous, then you cannot also have a standalone procedure or standalone function called miscellaneous. Okay, so select text from DBA source where name equals miscellaneous. And there we go. There's our definition. So now if you wanted to modify an already existing package, once you run this query, you can then save it in your buffer, and then you're just going to tack to the beginning of this, create or replace, and then modify it. Okay, so I just went ahead and I copied it, and now I'll paste it. Okay, so this is now in my buffer, and I'll just say create or replace package. Da, 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 da. Okay, that looks good. Now, let's go ahead and add a function to this. So function, the function name. If there are any parameters, you'd put them in parentheses right here. In our case, we have none. And then the return data type. So go ahead and save this, and we re-execute it. So our package was created. Now, since we do have a function here, we have to actually have the package body. So that's where we'll say create or replace package body. Okay, so I went ahead and typed in the rest of this. Now I purposely made a typo in here just to show you what to do when you get a compilation error. It's just like when you get one of those errors with a regular procedure or function. You simply say show errors. Well, it's saying, okay, it's complaining about line 4. It encountered the symbol end when expecting one of the following. Let's look at line 4. Okay, well, actually, let's look up at the beginning of our definition for function. Do you see how we're missing the begin keyword? Okay, so we'll just go ahead and go in there and make sure we have that. And then re-execute it. Now our package body was created. And with your functions, you can call it actually from a SQL statement. So select package name dot the function name from dual, and there we go. So granting execution privilege on a package is just, it works the same way as granting execution on a procedure or a function. You simply say grant execute on, and then the package name, to, and then the list of users. If you say public, then you give it to everyone. So now if I logged in as Scott, I could then use this package. So you see here that I'm logged in as Scott, and when I'm accessing this package, notice that I'm using a fully qualified notation. That's because the package belongs, I was originally logged in as sys. Okay, so this package belongs to sys. So I say sys.miscellaneous.getCodename. Let's add more to our package here. What I'm showing you now, notice here that I called my file here p.sql. What's typically done when you're creating packages is to put all of your statements into a file and then simply execute the file. See here how my specification is defined up here, and then I have a / to execute it, and then I have my body and a / to execute the body. Okay, so what I'm about to show you is how we can implement function and procedure overloading. Okay, now this is a concept that's actually taken from Java and C++. Overloading simply means that you've got more than one function or procedure with the same name but a different signature. For example, here I have two functions called addNums. Okay, so see the first one is taking two numbers as the parameters, and the second one is taking an array type. Okay, so here my array type is called num array type, and I actually defined it right up here. So really it's just a table of numbers. Then when you implement your function, you have to implement it twice for each one. So here I'm returning x plus y, and in my second function, I'm actually creating a loop and looping through each and every one of those elements. Now, here is my function definition. Notice here that I defined a variable called total. This total variable is local to the function. In other words, it only has meaning within this particular function. We can't reference it from outside the function. When you actually call the function from a SQL statement or from an anonymous block, Oracle is dynamically going to know which one to call depending on what you passed in. So let's go ahead and execute that. Okay, my package was created, my package body was created. We can do a description on our package. And then when we call it from a SQL statement here, notice I'm passing in two numbers, so it knows dynamically to call the first function that takes two numbers. And see here, we can call it another way. In my declare section, I'm just declaring a variable called nums, and it is of type miscellaneous.numArray type. And then these next few lines, I'm just initializing it to contain 4 elements, numbers 1 through 4. Okay, so that initialization ends right here on line 8. And then on line 9, I'm adding the numbers. I'm passing in that array type, and I'm assigning it to my bind variable that I've already declared called r. Okay, so we execute this, and then we can print r. So you see how nicely that works. A thing to keep in mind when you're doing overloading is that your signatures must be unique. In other words, you can't have two functions with the same name that both take in two numbers. That's just illegal. Hey, let's talk about the security of your code for a second. The way we have our code right now, you can just open up that SQL file and see the specification and the body. It's plain as day. What if you want to hide the actual implementation? You want to encrypt the body so the end user doesn't know how you actually implemented something. Well, we can do that. What it's called is wrapping. So here's our original SQL file, and we've got our spec up here and our body down here. What I'd like to do now is separate them into two different files. I'll have one for the spec and one for the body. In fact, I've already done that for you. Our first file is called p_spec.sql, and our second file is p_body.sql. Okay, so like I said, what I want to do is hide the body code. So we have a command line executable called wrap that's going to be under our Oracle Home bin directory. And so here I navigated to my Oracle Home, and I'm listing all the files that begin with WRAP. There we go, wrap.exe. So make sure you're at your command prompt, your OS prompt. So wrap, and then the iname, which is your input file. So here it's pbody.sql, and then your output file name. That's an optional parameter. By default, it will give the same name with the .plb extension. Okay, so there we go. So this file here is actually going to be encrypted. If you try to open it up with a text editor, it will not be readable. And it is now encrypted. So once you wrap something up, you cannot unwrap it. So wrapping is one of those things that you would do at the very end of your development. So see, we can still do a describe on our package, not a problem. So really what you're going to do is ship your product in wrapped format if you want to, and then tell the end user, hey, you need to execute it, just like they would execute any other SQL file, the @ sign or the start command, and run it. As a DBA, one of the proactive things that I like to do is to see if there are any objects in my database that are invalid. Okay, so I'm doing a describe on DBA objects. We have owner, object name, and status. Okay, so status can either be valid or invalid. So I'm only concerned with the ones that are not valid. So select owner, object name from DBA objects where status does not equal valid. And here we go. So let's focus on Scott's schema here. It looks like he's got several objects that are not valid. So one of the utilities we have, this is actually a package we can use. The package is called dbms utility. And in that package, there's a procedure called compile schema. And that just goes through this schema that we specify here and tries to compile all the different things in there. Okay, so we go ahead and execute that. Now, it might still come back with errors, but at least at that point, we can let the user know, hey, we've got some things that you need to recompile or fix. So then we can run this query again and see if there's still any invalid things. Okay, so they're still invalid. So at that point, what I would do is capture this information and send a little email to Scott. Well, we've covered some of the more commonly used packages. Keep in mind that there's a lot more out there available to you. You really should go to Oracle's documentation and just take a quick view at all the different packages available. You should also feel pretty comfortable creating packages, both the specification and the body, as well as looking at your data dictionary views. I hope this has been informative for you, and I'd like to thank you for viewing.